a vertical asymptote will approach some line. The graph, whether it's going up or down, it can do either, but the graph will approach some vertical line, and we'll call that line x equals a on all of these. It's approaching some value, and that's how they would write it. Now, actually, this is not how we would write it in pre-calc. They wrote this in kind of how they teach you this in Algebra 2, but this we would actually write as a limit. So in this case, I'm going to translate this to proper limits. You would have limit f of x equals x arrow, and then the x is approaching a from the right side. That's what the plus means. So you'd have down here a plus, and this graph happens to be rising, so it'd be a positive infinity. That's how it would look as a limit. It's an ugly f, but that's how it would look as a limit right there. So that's how you translate that. That's all it's saying as a limit. This one would be from the left side, just rising. This is from the right side falling, and this is from the left side falling. You could write limits all the way across. I'm not going to do that here, though. Okay? Now, that's vertical because the asymptote's up and down. Next slide, there can also be horizontal. Now, horizontal is if you are going to the far left or far right, if the graph begins to flatten out and approach a constant. In this case, the constant would be b. And so the way a limit would work here is this graph, it's the right side. The x's are approaching positive infinity. And you would say it's approaching this constant line of, or constant value b. Whatever b is, that's what it's approaching. And so that's how the limit would look there on a horizontal asymptote. And we'll practice this a lot today as we go on. But that's just kind of for generalization on your notes. Okay, so with that, let's start some problems. I'm first going to take a look here at the parent function. So the parent function is just f of x equals 1 over x. So it says first sketch a graph of 1 over x. Now here's actually how I'm going to do it in the future. I'm going to go from algebra. The first question I'm going to ask you is when we do a rational, what are you not allowed to divide by? 0. So the first thing I'm going to find out where the domain does not exist. The domain will be all reals except for where the denominator equals 0. So you're not allowed to divide by 0. There's nothing to solve here, so that means my domain is going to be all reals except for 0. So just to write that out here so you can see it, it's going to be all reals except for 0. So it can be any other number, just not 0. If you wanted to, you could write it out long ways like this. Negative infinity to 0, union, 0 to positive infinity. This is saying the graph will exist everything to the left of 0, and this will be everything to the right of 0. But since it's a parentheses, it will not include 0. So you can say it either way. Now, in the future, I will do that first. And the next thing, before I ever do range, increasing, decreasing, any of those, is I'll come down and I'll talk about then holes and vertical asymptotes. This will describe the break. So we have a break at 0. That's what we're saying in the domain. Here's the rule. If that x in the denominator can be canceled out, that factor can be canceled out in the numerator, it becomes a hole because you can remove it. If it cannot be canceled, it's a vertical asymptote. Does this x cancel with anything in the numerator? Can it be simplified? Can it be removed? No, there's nothing to cancel. So we will not have a hole, because nothing canceled, but we will have a vertical asymptote at x equals 0. So what I'm going to do is come to the y-axis, draw a vertical line, and make it dashed. Let me put on here x-axis, y-axis. Make it dashed like that. Now, so far, all that I've done, that's on that cheat sheet that I skipped over real fast. Later, if you're doing your homework, you can use that cheat sheet to help you out. Okay, from here, I'm going to move on, and I'm going to do horizontal asymptotes. And this time, it's actually going to be singular, so I'm going to take that away, that S. And this is also vertical asymptote. There's only one of them, so I'll take away the plural. Horizontal asymptote, it follows 3 rules. You look for the degree, and you check to see if the degree is bigger in the top or bigger in the bottom. Remember, degree means highest power. Now, this does not have an x, so it's kind of like x to the 0 power. This is x to the first power. Which one has a higher power, the numerator or denominator? Okay, we'll call this rule BOBO. Now, what does BOBO mean? It means your power is bigger on bottom. Bigger on bottom. That's what the BOB stands for. Bigger on bottom means your horizontal asymptote is going to be y equals 0. That's where the last O comes from. Bigger on bottom, it's y equals 0. So I'm going to add that asymptote now. To my graph, I'm going to have this asymptote. Again, everything I'm doing, it's on that cheat sheet, but I'm just showing you how I'm going to do it today. So after I do holes, vertical asymptotes, after I do a horizontal asymptote, I'll then do the y-intercept. The y-intercept you get by plugging 0 in for x, substituting x value of 0 in. So it'll be whatever we get when we do this. So I plug in a 0, and I get 1 divided by 0. Am I allowed to do that? What's the problem with that? Dividing by 0. Not allowed to do that. I'm going to draw a line through it. AP test graders do not like to see anything's equal to something divided by 0. So I'm going to erase that so they know it's not equal. F0 is undefined. And I'm going to make sure I write this properly. So it does not exist. You could have said NA from the get-go. But once I start writing out that math, and I have that equal sign, I need to get rid of that and say F0 is undefined. That means it will not cross the y-axis. Finally, again, all this is on the cheat sheet. If you need to find your zeros, you set the numerator equal to 0. And you solve. Right now I have 1 equals 0. Can 1 ever equal 0? No, there's no variable, so that there's not going to be any zeros either. NA, none. So from here on out, we will use the calculator, but this first graph I'm going to give you, it's this C curve that goes through the first quadrant like this, and it's going to approach either asymptote on either side of the first quadrant. So draw a C curve like this, and because my power is odd, this is an odd function, all the powers are odd, since that's an odd power. Since it's odd, it'll reflect across the origin. You remember that. If you have a odd power, only odd powers, it'll reflect across the origin. Or you can say it's symmetric with the origin. Symmetric with respect to the origin. You could write it that way. Or you can just say it's an odd function, which is a lot easier to say it's odd. Okay, the last few things I haven't filled in yet. Let's take a look at the range here. Range means y values. How low does this graph go? Negative infinity. How high does it go? Positive infinity. Is there any break in between this? Any separation between the two pieces? 0. So it is very similar here. This one will be y does not equal 0, and that's because it's odd. If it were even, it would be different. And again, y is all other reals. Whoops, I put it x. Y is all other reals. It's just not 0. So you could write it that way, or you could write it this way. Negative infinity to 0, union 0 to infinity. All numbers except for 0. That's what we're saying. And finally, looking at the graph, does it increase or decrease? Let's take the first piece. What would happen here? Increase, decrease?
Decrease.
Decrease. What about here?
Decrease. No,
It also decreases. It never increases. Never increases. But if it's always decreasing, we could say, if you wanted to, it strictly decreases on its domain. So you could copy down that domain again. I'm just going to say it's strictly decreasing on its domain. So that's the gist of the parent function. So for the rest of the day, what I'm really going to focus on are not these review items. I'm going to do the new ones. So I'm going to do domain, followed by holes, vertical asymptotes, horizontal, y-intercept zeros, and then limits. Those are the things we're going to look at, and we're just going to give a lot of practice. Again, if you're at home and doing this, you have this cheat sheet right here to help you find those values that I'm going to be describing as we go on today. There was that word bobo I used a moment ago. Okay, with that, let's look at our next example.